aka Dr. Manda Analytics, and today I'm breaking down what DBSCAN is and how it can help us make sense of the growing chaos in Earth's orbit. DBSCAN stands for Density-Based Spatial Clustering of Applications with Noise. It's a widely used, unsupervised machine learning algorithm that helps uncover hidden patterns in large, messy data sets, like orbital debris, for example, especially when those patterns aren't obvious or very neatly separated for us. So how does this work? DBSCAN evaluates how densely packed your data points are. It uses two key parameters to make its decisions. First is epsilon. That's the maximum distance between 2 points for them to be considered neighbors. Then you have minimum points. That is the minimum number of neighboring points required to form a dense region, or what we would consider a cluster. Now, if the point has at least the base amount of minimum points, neighbors, you have specified with an epsilon distance, again that you have specified, now it becomes part of a cluster. Now, if not, it's marked as noise. That can mean it's possibly an outlier or an anomaly that's worth you further investigating. And because this method is unsupervised, DBSCAN doesn't need any labels to start with. It learns structure directly from the data, which makes it ideal for situations where categories aren't predefined for us or obvious to us. Now, why do we think this is powerful? So, unlike traditional clustering methods, DBSCAN doesn't need to know how many groups to look for in advance. So like a k-means or something like this, where you have to specify in advance. And it's really good at identifying unusual patterns, outliers that others might miss. That's that whole anomaly detection phenomenon. Now, how can we apply this to space? That's something I looked at in my research. Now, right now, Earth's orbit is packed with debris. Whether it's defunct satellites, rocket parts, fragments from collisions. Now, as mentioned in my previous videos, there's thousands of objects that are actively being tracked right now, but there's millions more that are too small to detect right now on our current technologies or tracking methods, but they're large enough to cause damage. So those objects we expect to be able to track sooner than later as technology and methods of this advance. Now, I mentioned my research. In my dissertation, I applied DBSCAN to the SpaceTrack orbital dataset to help us better organize debris. Now, instead of tracking these objects one by one and making decisions, DBSCAN has the power to group the debris into meaningful clusters based on shared orbital behavior. Now, by doing this, we can reveal important patterns, like which objects behave predictably, which might have specialized identifiable patterns, and which others might stand out as potential threats. Now, again, that's potential because this is our initial risk assessment. Now, those noise points or those outliers are often the most critical to flag, which again makes DBSCAN, as I've mentioned, very useful for things like anomaly detection. Now, in space, this could assist in supporting conjunction assessments, which could assist agencies like NASA and ESA to predict collisions faster or more accurately. Now, with tens of thousands more satellites expected to go up into orbit by 2030, organizing space debris is becoming more and more of a critical issue. Now, when we involve machine learning and tools or applications like DBSCAN, we can provide new ways to protect our satellites, reduce costly maneuvers, and keep our orbit safe. Now, one thing to note is, if you're not a space junkie like myself, note that this isn't just used in space, right? We can apply this to other industries as well. Now, in retail, DBSCAN can identify odd purchasing behaviors, potentially fraud, unexpected buying trends of customers. Now, in streaming, it can help group user behavior for better recommendations or spot account misuse. Now, in finance, we can use it to detect suspicious transaction patterns. Now, across sectors, DBSCAN shines even when data is messy, if it's unlabeled and it's full of sort of a hidden structure or risk that's not easily identifiable for us. Now, if all I've said makes you interested, you know how AI meets space, like and subscribe to my channel, and let me know in the comments, how do you see an algorithm like DBSCAN being able to assist either in space or in your field of study? Until next time, thank you for tuning in. Take care.